Okay, so what we're doing today is lesson or unit 3. We've talked about linear equations. This sort of continues. We'll be dealing with linear stuff until Christmas. Okay, that's our gift to you. Um, it sounds subtle, but we did linear equations. Now we're going to do linear functions. Okay, so it sounds a subtle difference, but this is the first time we start talking about definitions of functions. Okay, let's look at this. A couple corrections here in this example. A classroom is arranged below. There are two horizontal rows of desks. Assume that you always want to have the same number of desks on each row. Okay, you're not allowed to add or remove desks. I first read this problem differently, but what they're saying is a row has how many desks? Five. Okay, so a row has 5 desks. Okay, so if you look at it right here, I see a class with what? 2 rows or 10 desks. Okay, let's think of what's reasonable in a classroom. Like, okay, would it be reasonable to have a class with one? Just think of here, a class with 1 row of 5 desks. No, you typically have more. Our class size is what? 18 to 20. So we would typically have how many rows? 4. Okay, that would handle most classes here. Do you have friends in public school? What are their class sizes? Yeah, so they may have 30 or 35. So they would have how many rows? 5 would be 25, right? 5 times 5. What do you think they would have? Come on. 30 and 35. 6 or 7 rows, right? Okay. What? The 6 or 7? You know, it's crazy. Like 6 or 7 in pre-algebra shows up every single day. And I wrote that book before 6 or 7 was a thing. So like I hate to say I was trendy before the trend, but I wasn't. It's just it comes up all the time, and you guys are more mature than they are. I lose them when 6, 7 comes up. So anyway, okay. So reasonably, okay, we're going to have something like maybe 2 to 7 or 8. That would sound reasonable for most classrooms. Now, this is a very subjective question. I'm not going to give this on the test and there's a right answer. But typically in this setup, somewhere between 2 and 7 or 8, that's going to handle most class sizes here in our country. Okay. So then what kind of numbers of desks are going to show up in these rooms? If I start with 2 rows, 10. So I'm going to have 10 or what? 15 or what? 20. I'm not going to have 21. Why? They're all rows of 5. Okay. So it's going to go up to about what? 8 times 5 is, I'm going to go with 40. So this is sort of what's going on here. So I've got rows and I've got number of desks. One of those things is a function of the other. What do I mean by that? One of these numbers is a function of the other number. What do I mean by that? Yeah, so the number of desks is what? A function of the number of rows, okay? So welcome, come on in. Okay, so if I look at this, what we have here is a relationship or a relation. There's a relation between the number of rows and the number of desks. Okay, so a relation is just two sets of data and I've put them together in some kind of relationship. So if I think about the number of rows, if I have 2 rows, how many desks do I have? 10. 3 rows, 15, and so forth. So all I have to know is the number of rows, and that tells me the number of desks I have because I have a relationship that there are 5 desks in each row. So in this one, the input is called the domain. In this problem, what is the input? The number of rows. And once I know the number of rows, the output is what? The number of desks. The output is called the range. Okay. So the domain of this relation, what is the domain of this relation? 2, 3, 4, and 5. So it's a set. You can write it with the curly brackets or not. I think it's okay. That's the domain of this relation. What's the range of this domain of this relation? Yeah, 10, 15, 20, and 25. Okay. So the domain is always the set of inputs. The range is always the set of outputs, you know. So for example, I could have a function or a relation like the number of points you missed on the test and then your score. Okay, so the input would be how many points you missed and the output would be your score on the test. Now, we get very specific, and you'll see this word all throughout the rest of your math career here. A relation is called a function. It's a very specific kind of relation if one thing happens. Every element in the domain, the input, has only one corresponding element from the range. So everything in the domain only gives you one unique answer in the range. So let's look at this. Look at our thing with rows and functions, okay, the one we just did. A function means everything in the domain only gives you one unique answer in the range. Is this a function? Because if you input 2, what answer do you get back? 10. Would you ever get a 15 from a 2? No. So you don't get 2 answers from one number. So every number only gives you one answer back, okay? What if I were to, yeah, so that is a function. So yes. What about if I flipped it around and I said 10, 15, 20, 25, and I did 2, 3, 4, 5. Here's my domain, okay, and here's my range. Is this a function? Yes or no? Every element in the domain only gives you one answer in the range. How many answers do you get with 10? One answer, you get 2. You don't get 2 and 3 back from 10, okay? You only get one number back, okay? So this is a function. The domain of this function is what? 10, 15, 20, and 25. The range of this function is what? 2, 3, 4, and 5. So it is a function because everything in the domain is only giving me one answer back from the range. So again, the relation is just the association between two data sets. So, pardon me? It's one of the things I'm not going to count off now. Maybe in high school someone will, but I'm not going to count off for it now. Just list them out. Okay, Lily, class participation. What is a favorite food? Egg roll? Okay. Let's go. Bryce, what's a favorite food? Pizza. Okay, Bryce. Caleb, what's a favorite food? What is it? Chicken. Okay. So Caleb. Stella, 2 favorite foods. Okay. Now let's look at this. So the input was what? The name, and the output was, yeah. So let's look at this. What is the domain? The names. So Lily, Bryce, Caleb, Stella. That's the input. What was the output? The foods. So we had what? Egg roll, pizza, we had chicken, and we had pasta. Now chicken happened twice, but I don't need to list it twice in the range, okay? So I've got the domain and the range. Now, if this is a function, here's my domain, okay? Here's my range. Right now, it's a relation. The question, is it a function? If it's a function, everything in the domain only gives you one answer back in the range. So I only get one answer back from this. I only get one answer here, one answer here, but what happens with Stella? 2 answers. So this one gives me two different answers. So this is a relation, but it's what? Not a function. Okay, so this one is not a function. Because the input for Stella gave me two different answers. If it's a function, I only get one answer. It's not Stella's fault because I made her do it. Okay, so I sort of set her up on that one. Yeah, because there would be two chicken. Chicken would give you two different people's names. Okay, so if Stella had said pasta and we'll say Brussels sprouts, then the inverse would have been a function. Okay, so. Now, so a function is a relation with the property that every element of the domain is only paired with one element of the range. So it means your input variable only gives you one answer. If I'm talking x's and y's, what's my input? X, my output. So if I'm talking about x's and y's on a graph, every x will only give you back one y, okay? So if an x gives you two y's, it's not a function. So let's look at this one. This is called a mapping. This is a relationship between a domain and range. Is this a function? So what's the definition of a function? Every domain only gives you how many answers? So how many answers do you get for -3? -2. All of these what? These are all giving you one answer. This is a function. Now what if it went the other way? If this was a domain, that was a range. That's not a function because I would be getting multiple answers for that one. So then look at this one. This only gives you one answer. This gives you one answer. This gives you one answer. This is one. This is a function. Yeah, it looks confusing, but just trace them out. Every domain element only gives you one answer back. What about the next one over there? Not a function because what? Yeah, you're getting two different answers for -3. So this is not a function. What about the next one? So the definition is every input only gives you one answer back. Okay, so each of these is giving one answer back. I would probably take an argument either way on this one because you're not getting one answer back from this one, but you could argue this is not part of the domain if there's no answer. Like you could argue that, okay, this is the input, there is no output. So why that really is not an input if there's no output. So this one is just sort of confusing. Yes. I would probably not put this one on a quiz because it is ambiguous, okay? So you could really argue if there's no value for 7, then it's really not in the domain, okay? So I would argue this one either way, but let's just sort of leave it for the but it doesn't violate the condition. I'm not getting more than one answer back, okay? So in this one feels ambiguous, but again, don't worry about it for now. The other way I could define a relation is just give you ordered pairs like x's and y's. What's the domain of this guy? 0, 1, 2, 3. Yeah, 0, 1, 2, 3. What's the range? 1, 1, 1, 2. Yeah, so just 1 and 2. Okay, so the range is 1 and 2. Is this a function? Okay, because 0 gives you 1, 1 gives you 1, 2 gives you 1, 3 gives you. There is never an x giving you two different y's. So what I would look for if it's not a function, I would look for repeated what? Or what values? Use the words x and y. Repeated. If I had repeated x values, like if I had 0, 1 and 0, 2, this would not be a function, okay? The range is the y's, the outputs. So the domain is a set of all x's, 0, 1, 2, and 3. The range is the y's, 1, 1, 1, and 2. So 1 and 2 is the range. So the only numbers you're inputting there are 0, 1, 2, and 3. The only numbers that are output are 1 and 2. Okay. What about this one? What is the domain? Mm-hmm. Mm-hmm. And then what is the range? 3, 0, 5, 1. Okay. Is this a function? Yeah, every x value that I see is only giving me one value back for y, so yes. Okay. What about the next one? What is the domain of this guy? Yeah. Yeah. So what I see here is -2 gives me two different answers. Okay. The range is what? 2, 3, 0, 5, 1, 4. This is not a function. Okay. Because what I'm looking at is I get different answers for -2. So I see repeated what? X values. So when I see repeated x values, it's not a function. Now the other way I can find this out is if I look at a graph. Now, this is the x's, these are the y's. If I look at that graph, what are the x values on this graph? From where to where? 1 to 4, okay? Anybody remember how we did that in interval notation? Yeah. 1 to 4, all the numbers, that means all the numbers from 1 to 4. You would be wrong if you wrote 1, 2, 3, 4 here, because what? Well, here's 1, 2, 3, and 4, but what's the numbers in between? How many numbers are between 1 and 2? Infinitely many, okay? So I cannot list them, you know, because you've got 99 100ths, 99 over 101, 99 over 102, all of those, okay? So interval notation just says all the numbers from 1 and 4, including 1 and including 4. That's the domain. What's the range of this guy? 1 to 5, okay? Yeah. So the range is 1 to 5. The range is the only time you're allowed to travel on the y-axis and give me an answer. Every other time when I view a graph, I'm looking for the x values. But when I say the range, go on the y-axis. There are no y values until I get to 1. I continue to have y values until I get to 5, and there are no more y values, okay? Now, is this a function? Why not? Yes or why not? Emily, is it a function? The x value is what? Okay, so if I look at, let's just pick a point. What is, let's just say, this point right here? What is that point? 4, 1. What is this corner up here? 4, 5. Is it a function? No, because a 4 is giving you what? Two different values. So it's not just the 4 that's doing it, right? So what we can do here is we have what's called a vertical line test. If I draw a vertical line and it touches the graph more than once, what am I figuring out? Yeah, it tells me that there is an x value that's giving me two different y's. So if I can draw a vertical line, I don't have to find these points. If I draw a vertical line, it's showing you here's an x value with two different y's. So this is not a function. So if I ever give you a graph, just do your vertical line test. So what we've seen so far is I've given you a mapping like this, and you're able to tell, is there any x that's giving, any x is giving you two different y's or more than one y. I've given you a listing of points. You look for, is there any x that's giving you more than one y? If I give you a graph, the easiest way is just to draw a vertical line. If it touches your graph more than once, then you've got an x value or x values giving you more than one y. Now let's look at this one. Let's figure out the domain. What does the arrow mean on this thing? Okay, so it's going to go down and where? Down and left for how long? Forever. This one is going to go what? Down and right forever. So this is going down and left forever. And the other side is going down and right forever. So the domain deals with which axis, X or Y? Domain is the X values, okay? So on this graph, X values go from where to where? Yeah, negative infinity to infinity. With infinity, it's going to always be parentheses because you can never, it's not a number you can put your finger on. It's a direction. So it doesn't, you might be tempted to say it's going from negative 2.5 to 2.5. No, no, no. The arrow means it's going to go down and to the left forever. Yeah, it stops, okay. So in the previous one, there were no arrows. So this box was bound. It went from 1 to 4 and from 1 to 5, okay. We're not going to do a whole lot of this. This is more of an Algebra 2 concept, okay. The range means I travel on what axis? The y-axis. Okay, so there are are there y values down here? Yeah, even though I can't see them because these arrows go what? Down forever. So y values will start at negative infinity, but they will stop when I get to positive 4. So the range is negative infinity to 4. Yep, it is included. Okay. So that is the range. Now, is this a function? I said that I can draw what to tell if it's a function? Vertical lines. So if I draw vertical lines here, how many times is it crossing the graph? One time. There's no way to get it to cross more than once. So this is a function.
So it just has to be a vertical line for it. If there's a vertical line, if it's a vertical line, there's no function.
If the vertical line crosses the graph more than once, it's not a function. So if I had a graph that looked like this would not be a function because the vertical line is going to hit it more than once. Okay?
You do the vertical line test, does it have to be on the grid?
Pardon me?
You do the vertical line test, do you do it on
Any on the grids. I mean, you can just look at this and see, you can look at this and see that it doesn't double over anywhere. So like, I mean, vertical lines are only hit it once. So you should be able just to see that right off the spot. So the vertical line test will determine if a graph is a function. If the vertical line hits the graph more than one, it means you've got an X value giving you more than one Y. That's not a function, okay? Let's look at this example. A function is used to model a swimming pool. A hose fills a 10-gallon swimming pool at a rate of 10 gallons per minute. In a reasonable model, how much time would it take to fill the pool? So we got to figure out independent versus dependent variable or vertical versus horizontal. But I look at this key, this rate here, 10 gallons per minute. So let's write this way, 10 gallons per minute, okay? If this were the slope is what? Definition, change in what? Y over X. So if you look at gallons per minute, which of these things you think is your Y? Gallons, and your X? Minutes. So vertical over horizontal, okay? So the horizontal is my independent variable. It's the variable that just, I don't really have to do anything and I'm going to measure. In this situation, am I more interested in measuring the gallons or the minutes? The gallons. Minutes are time is going to march on with or without me, okay? But the filling of the pool is the action, okay? So the horizontal axis is going to be the minutes, okay? That's called my independent variable. It's the variable that like, this is going to happen regardless. Time will march on, but I'm measuring how much water is in the pool. So then the gallons, that's my vertical axis. So the independent variable is your horizontal axis. That's going to be minutes. The gallons is your vertical or your dependent variable, okay? Now, if we look at this, what would be a reasonable domain? So if I've got 10,000 gallons, this gallons per minute, how long is it going to take to fill the pool? 1,000 minutes, okay? So minutes is my domain, right? So a reasonable domain, what kind of numbers am I going to get? So numbers from 0 to where? 1,000. Okay, so this would be numbers from 0 to 1,000. That's the domain of this function. Okay, the reason it's not 2,000 because what would have happened if I waited 2,000 minutes? Yeah, the pool would already be full. So in this problem, that's a reasonable domain. Okay. Now, what is a reasonable range? Range is referring to what in this problem? Gallons. The gallons are going to be numbers between what? 0 and 10,000. Okay. So numbers 0 to 10,000. Okay. Now, is it possible that this is minutes? Could it be a half a minute? Yeah, so it's possible. It's not just the integers, okay? So I could have 3.5 minutes or 4.5 minutes. So it's really all the real numbers. So if I was more precise, it's real numbers, 0 to 1,000. If I had a problem that was talking about like the points you score per game, okay? Points per game, and you're paying, say, football, okay? Would you have 1.5 games of football? No. No. Football, you have one game, another game, another game. So this would be integers, not real numbers. I can't play 2.5. I mean, you could play 2.5, but you can't have 2.5 games of football. You have one game, 2 games, 3 games, okay? So those would be integer values. And that's what we're starting to think about here. So if we look at this, the volume of water in a pool can be determined at any point in time for any value of x, okay? So we've got something, I think this is a different one, but it's like this domain is continuous, meaning any number here works, okay? I could fill the pool for 1 hour, 1.1 hours, 1.2 hours, 1.3 hours. So any number. So this domain is continuous. Now, for continuous, the domain is continuous if it includes all numbers in the interval. Like if these were football games, I wouldn't have 1.75 games. But filling that pool any time would work. So it's a continuous domain. I also only plotted time starting at 0. Why did I not plot time in negative?
Because you can't have negative.
Yeah, it doesn't make sense. I don't fill a pool for negative 2 hours. Likewise, the gallons, I don't put negative 4 gallons in the pool. Okay, so I'm. Now, when I mean the continuous, in middle school, continuous means you can draw the graph without lifting your pencil. I mean, does that make sense? This is a continuous graph. It has no breaks in it, okay? That's the middle school definition. To show you how math will grow with you, in upper school, they don't use this definition for continuous. They say it is continuous if, at a point, if the function exists at the point and the limit exists at the point, and these two things match. Okay, I'm not going to test you over that. Okay, that's just showing you get to upper school, they're getting a little more precise with the math. Then you get to college, and here it is. A function is continuous at a point C if for every positive number epsilon, there is a positive number delta, such as the absolute value of x minus c is less than delta, then f of x minus f of c is less than epsilon. So it just lets you know that, we're doing math now, but math has to grow with you as you mature. So anyway, that's free. You're not going to be tested over that. Okay, let's look at this. A restaurant needs to order chairs. The number of chairs is determined by the number of tables. So which of these things depends on the other thing? Yeah, the number of chairs, the way it's read, the number of chairs depends on the number of tables. Okay, so what it means is tables is my horizontal axis and chairs is my vertical. Because I'm ordering chairs. I'm interested, how many chairs do I order? It depends on what? The number of tables. So tables, the number of tables, that's my horizontal axis. And then my vertical is what? Number of chairs. So presumably in this problem, you already have a set number of tables. That's the independent variable, is not changing. And then the dependent variable is the number of chairs that you're going to need to order. Now, let's think about what would be a reasonable kind of domain for this. So what kind of numbers? I'm talking about for the domain, number of tables. What kind of numbers? Yeah, whole numbers, okay? These are no longer real numbers. You don't talk about having pi tables, or square root of 2 tables. These are going to be whole numbers. So these are going to be positive whole numbers. I don't really want to consider 0 because if I have 0 tables, what's the point of this problem? We know how many chairs to order.
So would it just be real numbers?
0. So positive whole number, not real numbers. So you could say the natural numbers. So positive whole numbers or natural numbers, or you could just list out 1, 2, 3, 4, so forth, okay? So that would be the domain, natural numbers. What would be the range of this guy? 4
to infinity.
well, 4, 8, there we go, because I order chairs for each, 4 chairs per table. So the range is going to be 4, 8, 12, 16, and so forth, okay? So it's just getting you thinking about problems, domains, and range. Now, is this a continuous domain?
Yes.
So every number in between 1 and 2 is possible. Oh, this is not continuous. Continuous, like the pool, I could fill the pool for 1.2 minutes or 1.3 minutes, 1.4 minutes. I really can't deal with 1.5 tables, okay? Because I don't order chairs for a half table, okay? So it's not continuous. If I looked at this problem, this is what the graph looks like. So for 1 table, you order 4 chairs, 2, 8. So this is not continuous. In the middle school definition, you are not able to draw this without doing what? Lifting your pencil, okay? So this is not a continuous domain. We say that this domain is discrete, okay? One of my pet peeves is it's not this word. What does that word mean? Discrete. That's a different discrete. This discrete means, I don't want to embarrass Charlie, so, I'm going to be discreet when I hand this paper back so that people don't see. That's what that discrete means. Sorry to pick on you, Charlie, but I haven't even looked at your paper. So anyway, or, someone likes someone and they're going to be discreet about it, which means what?
Like not obvious.
Yeah, they're not going to post it on social media. Okay, so this discrete is different. Discrete here means that it does not include all the numbers in between. So number of tables is discrete numbers, okay? I can count, okay? So there may be, even though it's infinite, it's countable infinite. I can count these numbers. I can count the number of tables. It could go on forever, but I could still count them. But if I looked at the problem that was before with the amount of time filling a pool, I can't count all those minutes or all that time. I can't count all the different ways I could do that. 1.2, 1.3, 1.31. It's not a countable infinite, okay? Let's look at this one. A bowler pays $4.25 per game. So what I would do, I would write this out. This is $4.25 per game. Once I write it that way, what is the independent variable, the horizontal or the domain? Games. So the number of games. So the number of games is the horizontal. It's the bottom unit there. And then what is the dependent or the vertical or the range? Cost in dollars, right? So it just comes from looking at, this is the bottom. If you think about slope, change in y over change in x. Vertical, horizontal, okay? What is a reasonable domain here? Okay, bowling per games. What kind of numbers come back when I talk about bowling games? Whole numbers, right? So it's your natural numbers, right? So it's 1, 2, 3. You can write it like that. You can say it's the natural numbers, positive whole numbers, either way. So natural numbers, or you could say positive whole numbers. The reasonable range. Now, is this a continuous domain? No, I don't pay for 1.5 bowling games or 1.6 bowling games. Okay, so then the range, what would happen if I had played one game? $4.25. You played 2 games, $8.50. 3 games, what is it, $12.75? Okay. So basically it's multiples of what? 450. So it's multiples of 4.25. Is $5 in the range? No, because you're paying 4.25 per game. Okay. A car travels 25 miles using 1 gallon. So this is 25 miles per gallon. What's the domain variable? No. This is change in what? Y over X, right? So the gallons is the horizontal. And then miles is my vertical, okay? So the domain is which one? Gallons, okay. So think about gallons that a car can use. What kind of numbers is that? It's continuing. I could use 1 gallon, 1.1, 1.2, 1.3. So these are positive what? Not natural, real numbers. Okay, I could use 0.6 gallons, okay? And then the range for every gallon is what, 25 miles? But what would happen if I traveled half a mile? 12.5 or a third of a mile. So is it going to be 25, 50, 75 or no? No, it's what? The same thing. It's what? All real numbers. So positive real numbers. It's not natural numbers because I could use, 2.6 gallons or 2.7 gallons, okay? So in this one, it's like the games is something I can count. Bowling games, 1, 2, 3, 4, 5. It doesn't make sense to count and say 1.6 bowling games. In this one, I can count gallons, but your car can use not just discrete number of gallons. It can use 1.6 gallons, 1.7 gallons. So this one has real numbers, okay, as well. Is this one, so this is a discrete domain. This one is what? Continuous, okay? And that leads us up into the homework, okay? Let me stop this.